Welcome to homework.
Okay, so we need to look at these molecules, these amines specifically, and talk about which of them can be made via the Gabriel synthesis. And I think the most important thing here to notice is that only primary amines can be made by the Gabriel synthesis, right? So you can only make primary amines only, right? So that's what we use to decide here, right? So A, butylamine, yeah, that's primary. We can make that with the Gabriel synthesis. 2-phenylethylamine, right? Or 2-phenyl, sorry. Uh, why is D out of, okay, so it goes A, D, B, E, C. What the heck? Okay. B is isobutylamine, right? That's fine. Yes, looks good. Okay. C is tert-Butylamine. Sorry. No, this is not fine. This is secondary. Nope. Isobutylamine is not okay. Okay. Tert-Butylamine. No, because this is tertiary. Tertiary amines are not primary amines. Okay. D. We've got 2-phenylethylamine. Right. Uh, this is not going to do. Um, we can only add NH2. We can't add, sorry. Right. We need to start, so the source of our nitrogen, if you recall, for the Gabriel synthesis is this. This is where our nitrogen comes from, right? Uh, we have to be able to deprotonate it, right? So we can't have anything but a proton there, right? So that means we can't add, for example, if we wanted to break this down and say, oh, well, it is primary, right? Because that's primary. No, because we would have had to have started, sorry, I crossed the wrong side out. We would have had to have started with this molecule with this nitrogen right there. And that's just not possible, right? So not only does it have to be a primary amine, it has to be an NH2 amine, right? So it has to be a primary amine, it has to be a primary substituent, and the amine itself uh, can't have anything other than 2 hydrogens on it, right? So D is also not going to work. This is no good. Okay. Next, we've got E, N-Methylbenzylamine. Oh, my bad. Actually, I drew the wrong product here. D is possible because 2-phenylethylamine, excuse me, actually is this. And that is possible. Okay. That's primary amine. So, apologies. This one is possible. Okay. Now we move on to N-methylbenzylamine. And this is more of an issue. Right, so we've got benzyl and methyl attached to our amine. And this will not work for the reason I stated incorrectly about D, right? We can't, it has to be a terminal amine, right? It has to end in NH2. We can't have NH methyl or NH-benzyl. Okay, finally, we've got aniline, which is simply benzene with NH2. And this won't work because this is not a primary carbon, right? Same reason that the isobutyl or the T-butylamine don't work. Right. Okay, so now we can step through what the synthesis process would look like for A and D, since we know those would work. Okay. So we start with our phthalimide. React it with KH, and then we get our strongly basic and also somewhat nucleophilic potassium phthalimide. Then we simply react it with a primary alkyl halide that matches what we want our amine to look like. So if we want amine that's coming off the end of a propyl chain, then we need to simply redraw this, but with bromine there, right? And so we would redraw, in this case, the same molecule, but with bromine, where we have the NH2, right? So for the for the butylamine, NH2, bromine, and we will get our product. Or not quite. We will get still have to set the amine free, so to speak. Okay, react it with hydrazine and heat it. Finally, we will get our butylamine plus phthallohydrazine. Okay. And if we want to do the other thing, we would simply, the other molecule, with the same reaction, but with that, and our product would simply be this. Oops. Okay.